video I show you a simple workflow to integrate 3D objects into an image. The goal is to make the 3D model look like it really exists in the image. For this I use images from background.com. On the home page we scroll all the way down. There are 360-degree HDR images with matching backgrounds. There you can register and get started right away with the starter pack. You will notice that there are different resolutions of the images. For example, there is one with 10K and a lower resolution with 1K. There's also matching HDR that is very high resolution and 312 megabytes. This HDR offers many exposure levels and there is also a 4K version. Of course, there are other providers for such files, such as hdrhub.com. You can also download free material with a suitable background here. There are also package deals. They're at reasonable prices. Now we are going to start directly in Cinema 4D. In Cinema 4D we will create a standard redshift camera. In the camera settings we select background. We click on override and upload our background image. I decide to use the image with a lower resolution. I drag it into the designated path and view it through the camera. The image looks a bit distorted, so it's important to use the right resolution. More precisely 1500 per 1127 pixels. I enter this resolution in the output settings. This should fix the distortion. Now I would like to adjust the perspective. For this I will just use a surface. You can use any 3D model of your choice, for example a car. I also add a sphere and position it on the surface. To make the sphere rounder, I increase the number of segments in the object settings. I guess the focal length under object is about 50. If you work with photographers or have camera data, you can make more precise adjustments. I roughly adjust the perspective. The corner of the face should roughly match this mark. While doing this, I also note the horizon line. I adjust it again. This already looks quite fitting. Next, I want to add the HDR image. To do this, I will go to the light sources. I select the dome light. I navigate to Object. Under Texture, I load the HDR image. I choose the lower resolution version for performance reasons. Of course, you can also use the high resolution version to view the HDR in the background. Navigating back to my camera. Under Background, I briefly disable the current background. I rotate the HDR to inspect it more closely. It looks good at first glance, however it does not match the original background image. A comparison shows that the road looks different in HDR. The HDR was taken from a different angle than the background image. If I zoom in closer, I see a fence and a road leading to a skyscraper. When I rotate the HDR, I see the same fence. It's right here and I recognize the traffic signs as well. In HDR we are looking at the signs from behind, while in the original background image they are seen from the front. The HDR appears to have been taken at about the center of the road or median. Presumably between these 2 points. It doesn't match the background image perfectly, but it will probably do. I still expect a good result. If the image had been taken closer, the reflection would have been ideal. However, we will do our best to make the best use of the available material. I am aligning the image so that the skyscraper are visible in the background. I position it so that the skyscrapers are central. I make sure the picture is not crooked. Then I check the coordinates. I set the values for P and B to 0. After that, I fade the camera back in. I navigate to background and click on override. Then I start the rendering. I open Redshift, continue in render view. I select the appropriate window. I position it sideways to get a better view. After that, I start the render process. Finally, I adjust the HDR a bit. To look at the shadow cast properly, I zoom in closer. This helps us to better assess the situation. The shadow cast becomes clearly visible, especially at the tree where the light hits. You also notice the sharp edge of light there. Additionally, you can see the shadows of the plants. This allows us to adjust the light so that it is parallel. I briefly zoom in on the ground area and scale it up a bit. The sphere seems to float, so I adjust its position. In the coordinates, it is at 105. I set it to 100, though that it rests on the ground. I rotate the image to get a parallel line. The rendered image looks different than expected. This is due to the ASUS color management system. I disable color management to get more consistent results. To do this, I navigate to the settings in the render view. I select color management. Under view, I set it to untone map, so turn off color management. Now it looks similar to the original image. I'm closing the settings again. Next, I want to hide the ground and make only the shadow visible in the background image. This will help us better evaluate the overall image. That's pretty simple. I click on the tab and open the context menu with the right mouse button. I select render tags. Then I go to the Redshift object tag. I click on matte. Then click on override. I check enable to hide the top. And still enable the shade. I also want a drop shadow similar to the one in the background image. I achieve this with an infinite light. The light source must be properly aligned. It is visible that the light hits the sphere from the right. I take the light and turn it. I position it so it comes from behind. I direct the light upward to create a drop shadow. I adjust the position further to get a harmonious shadow gradient. I enlarge the top a little more. This way I can see more of the shadow. I adjust the window size. The top could be a little bigger. The shade didn't have enough room. I adjust the light to match the shadow cast. The window may appear too large. I turn the light down further. This way the shadow is quite okay. Actually, the shadow looks very sharp. In reality, a shadow runs softer. First sharp, then gradually blurrier. I simulate this effect by adjusting the infinite light settings. To do this, I navigate to the Details tab. Under Softness, I adjust the shadow with a slider. This softens the shadow. For more contrast in the shadow, I increase the light intensity. I go to the light settings. Under Object, I increase the intensity. For example, I set it to 5. That looks better already. This is quite okay. Now we want to analyze how the environment affects our material. The easiest way to check this is to put a specular material on the sphere. To do that, we go to the materials at the top. With a double click, we create a normal standard material. We drag this material directly onto the sphere. We open the material. Then we navigate to the settings on the right. Here I set the AOR value completely to 0 and the roughness to 0 as well for a perfect reflection. Now we notice two problems. The hues of the HDR are reflected and the gray area is visible. Ideally, the road should be reflected and also not so saturated colors. Here are several ways to adjust this. The easiest way is to click on the dome light. Go to Tab Object, adjust the saturation, maybe to 50%, that should fit. Maybe we also need to adjust the intensity, for example, to 3. That looks better already. We could reduce the saturation even further at about 30%. That integrates it better. Next, we want the bottom to be reflected. Just like on the real road, that can be done quickly. We create a standard material again and put it on the top. The material is replaced with a specular material. Now we open the newly created material. Double-click to open the node editor. I want to use the texture of the road or background. I want to project the image directly onto the top. The image should reflect as if it were coming from the top. To achieve this, we navigate to the left side of the menu. There we select texture where we find a specific node. This is the camera map node where we can project the texture based on the camera perspective onto a geometry. We connect this node directly to the base color of our ground material. Using out color, I drag it onto the color option. At first, the texture is displayed in black since it has not been assigned yet. I click on the node, go to settings. Under path, I load the desired image. I select the background image already in use. I drag it into the designated field. The result already shows the first changes. Now I want to make sure that the right camera is used for the projection. I scroll down further. Here I can select the camera. Here I can select the camera either without the picker or I drag it in here. This fits like this. The result looks good. Now I return to the settings of my ball material. We click once on the material. I go to the AOR value and click on Reset to Default. Under Roughness, we use the default value of 0.2. Let's try a different color. For example, a bright red. Now let's adjust some more settings to make the rendering more realistic. First, I want the material to be reflected on the ground. Not only the reflection, but also the color should affect the floor through the global illumination. We achieve this setting simply by using the object tag. We simply increase the value for diffuse scale. This will transfer the red color to the ground. This can be seen a bit in the back. Next, we add a reflection on the ground. For this we use the reflection scale. This means that the reflection on the ground is set depending on the material. Using the reflection scale, we regulate the intensity of the ground reflection. In this scene, it doesn't make sense yet. It makes sense on wet roads. Therefore, I remove this effect from the scene for now. Another detail that stands out is the irradiation of the bright area here. This is caused by the light of infinite light. I go to the infinite light to the details section. We set the strength of the reflection under reflection. Under reflection, I could remove this value, for example. This would cause this bright area to no longer be present in our rendering. So far, these are the changes we have made to the various settings. Now we want to start the rendering and render it in two parts. Only render out the sphere and its shadow. After that, we compose this in Photoshop to conveniently swap out the background. Let's click on RGB at the top of this button. Let's switch to the alpha channel, which is currently completely white, but this results in a useless alpha channel in pure white. Now we need an alpha channel. To do this, we go to the Redshift object tag. There at the bottom, we see an option called Matte. Under Shadow, we also select Effects Alpha. Now we have an alpha mask for the ground, our object, and the shadow. This is perfect for further use. Now we want to cut out the background. With this, we can just paste this into Photoshop. To do this, we simply go back to the Redshift camera, then go to the background section here. There, yes, we have selected the background image. There we can go under color right down here to alpha. And then we can pull on this slider here, and so we can also cut out the background image completely. So then we are almost done so far, and now we could render the whole thing out. Then we would have a wonderful alpha channel here. So I will switch it back to RGB mode, and then we will go to the render settings. I'm not turning anything on here yet from the setting. Let's leave it all on standard here as far as quality goes here. So we are going to save up here. So the most important thing you need to make sure of now is that you also have alpha channel enabled. You're not doing multipasses here now. I'm going to disable that. Then we take now her times under format, quite simple, times PSD. There we go, then path. Now specify another depth of 16 bits here. Here above I specify path, where to store the whole thing. Let's just click on render, then let's go to the layer here. And now we can see here, if we switch to single pass, the alpha channel. Let's open this up in Photoshop. Here we have our normal rendering now. When I go to channels, I see the alpha channel. Then I press Ctrl A to select everything. I use Ctrl and C to copy this alpha channel to the clipboard. Then we go back to RGB. I will cancel the alpha channel. I go to my levels. I create a mask at the bottom. I press the Alt key and click inside the mask. Press Ctrl and V. I return to the mask. Then we see how the object is punched out with the matching shadow. And last but not least, we add our background image. We drag the background image directly into the file. We place it accordingly. And then we just place this layer underneath. So now we see our rendering above it. Now I can apply different effects here. For example, changes to saturation and hue. I can change the hue to match the image. Of course, we will only let these adjustment effects the bottom layer. With that, we are basically done. Now we can adjust everything to our liking, as is common in Photoshop. I can even mask out this shadow to leave its color unchanged. Now we have seen how we can render a 3D object into an image relatively quickly.